Greetings, programs. Welcome back to Stegosaurus Studios. It's Mike, and I am here out in the shop. It's a rainy day, so what better day to go out in the shop when you can't do anything else? So this is episode 20. I've got a whole bunch of frame sitting here in front of me. You can't see it in the shot, but frame is underway. But I want to start. I'll go over that in a second segment, but right now in this segment, the opening segment, I want to talk a little bit about the aluminum extrusion. So I didn't know anything about. I didn't know what this stuff was, and then I actually met with Malcolm, and he said, I was talking about what I wanted to do, and Malcolm said, well, why don't you use like 1010 or 2020 extrusion? And I was like, what's that? So he explained it to me, and I went and looked it up online, and this is a 1010, so 1 inch by 1 inch. They also make metric. So it makes an interesting shape there at the end. I actually didn't get it, but basically you can slide T-nuts anywhere along these slots, and therefore you can position connectors and everything anywhere you want. So you can get this, and they'll cut it to length. You can cut it yourself. So I did a mixture of both. Some of the pieces I had them cut. Some of the pieces I'm going to cut myself. They make internal and external fittings. So for example, this is an external bracket. So if you were connecting, let's see if I can be coordinated enough to do this. If you were connecting those two together, you could use an angle bracket like that on the exterior. They also, on the seat, when I was making the seat, I used internal connections. So it slides in to this one, and then it slides into the other one, and then makes the right angles. And then one fitting in particular, one internal connection in particular that I wanted to talk about is these cam fasteners. They look like this, and they require some additional machining, and I had 80/20 do it. So you can see this piece here has these holes drilled in them. So basically the cam drops in like that, and then this end piece here you then can slide, assuming again that I'm coordinated enough to do it, and you can slide it. And the reason I'm talking about this is this is the strongest connection that they make, is these cam fasteners. So for the base frame, the bottom layer, if you will, of the frame, I'm using all these cam fasteners, and then the upper layers I'm using these external brackets. So with a few places where I'm actually using the cams. Some of the other things that they make what they call pivot nubs. I've talked about these in the modeling. So basically it allows motion, right? So this gets put on the like that, and then this allows the motion. Another thing that we're using on this project that's motion is these slides. So and that's, for example, the steering system will pull on this back and forth, and so that is how the steering mechanism will work. There's a whole lot of stuff that I am not using. I mean, they have panel mounts, they have they can pressurize systems, they have just all kinds of stuff. So I'm not going to say it's cheap, but it's like if you were to try to do this with aluminum square stock, this is probably cheaper. And there's more than you can go to. There are a number of manufacturers. I used 80/20, which is out of Urbana-Champaign, I think, in Illinois. So I am enjoying putting this together. I think it's a good product, and I think it's going to be strong enough for what I'm going to put them through. So yeah. One other thing that I actually got accomplished before the last video, but I forgot to record, is so this is one of the Neo motors, and I've got the pinion installed. So this is the pinion that will drive the steering. So it actually have the rack right here. So it meshes with this. So this rack, let's just assemble. This rack it'll be on 2 of these slides, and then the motor the pinion will mesh with this, and will drive the steering back and forth, right? So that's the rack, that's the slide, and this is the pinion. So you can get these pinions from Neo. They make a couple different numbers of teeth, and they come in a little kit that includes the retaining clips and the key, because the shaft is keyed. And the retaining clips, by the way, are necessary because I found out that the pinion is actually a pretty loose fit. So don't assume that you're just going to put the key in and slide or press fit the pinion on. You don't even need to press fit it. You can drop it and it slides right down. So hopefully these little retaining clips will do their job as advertised and will actually stop it from moving. So anyway, I've only done one. I want to do some testing before I put the pinion on the other one. So anyway, that is the opening. And I'm once again recording this ahead of time, so I don't know what else. I know that we'll be talking about this thing you can't see down here, which is the frame. I'll go over everything that I've got assembled so far. Got my bandsaw out. Actually cut the rack into 2 pieces. That was the first time I'd used the bandsaw. So I'll be using it much more to cut the members that will go on this. So I think this should probably, well, I'm always optimistic. I think it'll go pretty quickly because this base frame actually went together very quickly, but I'm sure there'll be problems that I'll encounter in the future. So we'll stay tuned and see what happens next. Okay, so this is the front of the speeder. So you can see I've got the air spring mounted in here. So you'll see there's 4 arms. They're on pivots. They actually connect. This is the motor assembly, or the wheel assembly. It also has 4 pivot arms. So the 2 connect. It goes in and connects like that. So then as it rides up and down, this cage goes up and down and squeezes the air spring and that's what creates the shock absorption. So I forgot a piece. The reason I haven't put it together yet is on the bottom one, there's a crossbar, and then there's another pivot that needs to go, that screws onto that. And when I ordered the extrusion, I messed up this pivot, or the crossbar. So the crossbar is supposed to be here tomorrow. Once I get that, I can put this the whole front will be all completely assembled for testing. So just need that. So let's go look at the back. Sorry, I'm the only person here, so I'm the camera operator as well as the on-camera person. Let's see. I guess that's good enough. All right. So we have something very similar. We've got these 4 pivot arms here. And then it'll be duplicated on this side, and they create essentially something very similar to the front. The air spring goes here. I don't have the top, but it'll be here. It'll be housed within this square cage, just like on the front. So as it goes up and down, the shock absorber from the air spring will happen. The one thing that's a little different though is in this case, instead of going to a square frame like it does on the front wheel, it'll connect up to the kingpins, which I've got the new ones. They're way better than the old ones that were way too stiff. I haven't put them on yet though. They go in those two holes. So the kingpins, which are just basically right angle ball joints, will be there, and they'll connect up to this. And that allows this to turn as well as go up and down with the shock absorption. So what else is on here? This is the rack. So you'll see that is a rack there. It's got teeth in it. And I don't have any of this together yet, but this thing will slide back and forth as a unit. Basically, this plate here will get mounted, it'll actually be mounted on the front side like that. And then you'll see the pinion on the Neo motor will interface with the rack right here. So as the motor turns back and forth, the rack will go back and forth. There will be connected to this end of the rack will be a steering rod or a tie rod, which will connect up to a steering arm that'll be mounted here. But when this moves that way, it will pull and it will turn it that direction. And when it moves that way, it will push it and it will turn it the other direction. So that's how the steering actually works on this. So I just need to put all the rest of this stuff together. Wish I'd have brought that piece out, but there is one complication, which is on the pivot that goes underneath this, on both this and the front. So let's go back into the shop and I will talk about that pivot. All right, I'm back. So this is the pivot thing that I wanted to talk about. So the air spring, whether it's the small air spring or the longer one, it screws into the top of this. So right now I have this in plastic, just as a placeholder so that I can put things together. So here's the complication one, and I should have brought the air spring, but, and you know what, hold on. I have one right here. It'll be easier to do this with it in hand. All right. So on one end, it just screws in. There's no air connection on this end. So that's just the top mount. The bottom has the air connection, is this 1/8 inch NPT in the middle. And then this is the mount. So the mount just screws in. I wasn't really thinking about what these threads were. And so what I actually designed was I said, well, we'll just thread this in the top and then we'll have an air connection on the side and that'll work. And there's a problem with that. So as I said, this central where the air connection is, that's 1/8 inch NPT, National Pipe Thread. So NPT is a tapered thread, and it is designed for sealing water or air, any kind of fluid. So as you screw that further and further in, what's happening, because it's tapered, is it's pressing the shoulder of the one-piece thread onto the shoulder of the outer piece's thread. And so that creates a seal, because as you crank it down, you're pressing those two sealing surfaces together. So again, that's the inner connection here. The outer connection is UNC or UNF, depending on which air spring you're talking about. That's Unified National Thread. That's a straight thread. It is not designed to seal against air. So had a meeting of the minds and we decided that it wasn't going to work. We didn't weren't sure we'd be able to have it seal adequately the air pressure. So basically I need to redesign this part somehow so that I can get an airline up into, essentially, right, an airline up into the bottom of this, come out the bottom, and still allow it to pivot. So I have to do some redesign on that thing. And I don't really know how I'm going to manufacture that because I want it made out of aluminum, and I don't really have the technology to make that part. So I'm working with the local guys to figure out how we can get that done. So okay, so that's the status. The last segment, I know I ended the last segment with a statement that I was hoping that this construction would go quickly, and I was so wrong. It's going slow because there's setbacks like this. It's been raining, which has made it hard to get in and out and do stuff. I have lots of excuses, but anyway, it's going really slow. Okay, so I think that's going to be the end of this episode. With the segments that I've recorded, should be enough time. So thanks for tuning in, and next time maybe I'll have it in a semblance of all together, and we can start some of the testing, because that's where the excitement really happens. So anyway, thanks again. Talk to you later.